Hi, where we take a look at machine learning and deep learning in computer vision. And we're starting with machine learning in computer vision. So what exactly is machine learning? Well, machine learning has been synonymous with artificial intelligence over the last few years, and it basically entails how we can make software or computers learn. So essentially, machine learning is actually statistical analysis or statistical predictions repackaged. And the reason it's been repackaged is because it's shown enormous growth over the last 5 to 10 years. And that's mainly because a lot of these machine learning libraries are becoming so easy to use in high-level programming languages like Python. And combined with all the breakthroughs in different research, different algorithms, things like sklearn, which has made machine learning so easy to use within Python, combined with cloud computing and the use of GPUs in training complicated deep learning networks, it has made machine learning so popular in such a demand field. That is why data science, that career of data science, has been exploding over the last few years, because now we have the tools to analyze all this data we've collected over the last 10 to 20 years. But what is so special about machine learning? Well, think about something here. Think about machine learning versus explicit programming. And what is explicit programming? Well, imagine we had to determine what person would likely buy, say, our premium life insurance package. Now, there are several factors you can look at. You can look at age, income, gender, career, education level, job title, number of children, and a lot of other data. However, setting hard rules to determine which person is likely or not, and how do we even measure likeliness? Do we give it a score? Is it a yes or no? We need something that can take all of these inputs and output basically a probability or like a level or ranking of a score to indicate how willing they will be to buy insurance. Well, machine learning solves this, because imagine explicitly if we had to say someone over 65 making over this amount, who is male or female, has a bunch of these careers. That's like very, very complicated set of rules. And imagine you have to give different levels of ranking, like 1 to 5. You can see how complicated that can become. So now let's talk a bit about the 4 types of machine learning. And arguably the most powerful machine learning algorithm is neural networks. And neural networks are the same thing as deep learning, but we'll discuss that more later on. However, let's look at the 4 main types. There's supervised learning, unsupervised learning, self-supervised learning, and reinforcement learning. Now, we're particularly going to spend a lot of time on supervised learning, but let's discuss what each of these are so you have overall knowledge of what machine learning is and what it can do. So let's take a look at supervised learning, which is the most popular form of machine learning that's implemented today. Basically, what supervised learning does, it takes a bunch of input data. These are called features usually. And once it into our machine learning algorithm or model, it outputs either a label or a number indicating something that we desired. So example with willingness to buy insurance. Imagine this is all our data here. We have age, income, blah, blah, blah. We just input this data into an algorithm and we get bang, a score saying how likely that person is to buy insurance. That's pretty cool. So how does our algorithm learn, or how does it actually do what we want it to do? Well, we have to give it example data. So what does that mean is that we give it a lot of label data. Label data means example data like we'll teach a child. So you basically tell the machine learning algorithm, let's say if we're doing a spam example, these 10,000 emails are spam, these 10,000 emails are not. The machine learning algorithm looks at a bunch of different attributes in that data, and now we can send a brand new data input to that model and get an output. So that's essentially how supervised learning works. Now let's look at some supervised learning examples in computer vision. What we can do with supervised learning is that we can classify types of images. So you can do things like identify whether image has a cat or a dog, or basically is a pornographic image or not. You can do things like object detection. Object detection is these things here, figuring out these different objects in the sky. And image segmentation, which is separating different layers of the image. So we identify that this is a laptop, this is a cup in the foreground, this is a wire connecting the laptop, this is the desk. So you can do those things. That's called image segmentation. So now let's move on to unsupervised learning. So what unsupervised learning is concerned with is finding interesting clusters or clusters that belong together in input data. So in this case, we don't have label data. We are just giving an algorithm a bunch of data and we're telling it, figure out what belongs together. So for this example, you can think of these 5 inputs here. We have chocolate, vanilla, beef, pork, and chicken. And we send this data to an unsupervised machine learning algorithm. Consider something like k-means. which is one of the most popular unsupervised learning algorithms. And what it spits out is clusters that are close together using some sort of distance metric. Now, that's exactly what happens here. Let's assume it's examining ingredient components or chemicals in these food groups here. And it figures out that vanilla and chocolate belong to one cluster, which is like a dessert cluster. And these three belong to a meat cluster, which is this one here. So that's pretty cool. That's how it works. Now let's look at self-supervised learning. Now self-supervised learning, it follows a similar concept as supervised learning. However, the data isn't labeled by humans. And so how are these labels created? Well, it's often done using heuristic algorithms, things like autoencoders. Now these things are a bit beyond the scope of this course and get quite complicated. But an example of this is something that can predict the next frame in a video given the previous frames. So that's how we can use it in the computer vision world. Now let's talk about reinforcement learning. Now reinforcement learning is potentially very interesting. However, it's not totally mainstream in the AI world just yet because the applications are somewhat niche for now. However, there's a lot of potential to apply this to other learning fields, so especially in robotics as well. But how it works is the concept is fairly simple. Imagine you're just teaching someone, and when they make a mistake, you give them a penalty, and if they do something good, you give them a reward. So that reward-based learning is essentially how the algorithms in reinforcement learning learn. So how is machine learning done? So we talked a bit of things like I may have mentioned training or learning, but what exactly is it? So how is it done? So let's take a look at supervised learning, the supervised learning process in machine learning. So firstly, remember I said we need labeled data. Now that labeled data is often called the ground truth or human labeled data. It's essentially the examples that we give to an algorithm that tells it this is what it is. Figure out a model that can predict this now from new inputs. So how it works here is that we split the data. Let's use a cats versus dogs image example since this is a computer vision course. And we split it into a test data set here and a training data set here. So what's the difference here? Now the training data set is the data we are giving the machine learning algorithm to learn on or train on. So it takes this data and it looks at different things in it. Now if it's deep learning, it can look at a lot of complicated different things. If it's a less complicated algorithm, it's going to look at maybe different pieces of image. So it's going to look at different pixel values in different areas. So that's what it's doing by learning or training. So what is the test data used for? Now the test data is to test or assess the performance of your algorithm on brand new data it hasn't seen before. So you can get an accuracy level of how it performs on real world, or you don't have to say real world, but just unseen data. So firstly, after we have the data here, we basically fit that training the model on this training set. And then we evaluate the performance on the test data set. That's what I talked about. So that's the supervised learning process. So what exactly is this model I'm constantly referring to or talking about? So basically, a machine learning model is just a bunch of mathematical equations where we give it some input data and it creates an output out of it. So now that doesn't really help you too much, but that's essentially what a model is. And different types of machine learning algorithms create different models. All of these things are basically weigh things essentially on different inputs here to see how much should contribute to the output score. And then things like deep learning can consider different combinations and different how they move together. So it can get quite complicated if you look at the maths behind it. So remember I said the inputs are multiplied by something called weightings, and that's how we get the output. Now this is essentially a very simplistic form of what a model actually looks like. You can see it here. We have weight 1 for input 1, blah, blah, blah. Get an equation here and basically gives us the output in the end. So this is a basic level of what the equations look like. So now let's refer to some machine learning terminology that I'll often use in the next few videos. And you'll often hear if you're practicing this in the workplace as a data scientist. So this is some basic machine learning terminology that you'll often hear me talk about. So you have things like target data. Target data is essentially the ground truth labels or the human labeled data that we have in the training data set. Those are our targets. I can also refer to targets of the test data, but just remember there are ground truth labels that are referred to as the target data, okay? Now prediction is essentially what you think it is. It's just basically an output from the machine learning model given some inputs. Classes are essentially categories that exist in your data set. So remember in our cat versus dog classifier, those were 2 classes. Similarly, a gender one will have 2 classes. It could have more as well. Now classifier or classification refers to a machine learning model that outputs categories or classes. It doesn't output real value continuous numbers. It outputs or probabilities, although it could output probabilities in some cases by tweaking it. It outputs categories that your input data should belong to, like cat or dog. Regression is the opposite in a way, well, not essentially the opposite, but it's different, where it actually outputs the continuous real valued numbers. So imagine a model that's trying to predict someone's height or weight. Height or weight isn't really in categories. Essentially, it's measurements. So it can output like a height of 172.6 centimeters and a weight of 50 kgs of 120 pounds. That's what regression does. And validation or test data, now they're usually different things. However, in a lot of machine learning training algorithms, they can be considered somewhat the same thing. It's basically the data we test our machine learning model on. So it's supposed to mean unseen data, not the training data, any other data but the training data. Okay? So let's quickly summarize what we've learned in the video. Now, this video dealt with a lot of different things, and it dealt with machine learning in a very high level way. But I assume you now understand what exactly machine learning is, the types of machine learning, the step-by-step process by which we train an algorithm, in a supervised machine learning algorithm, I should say specifically, and what exactly machine models are, and some general machine learning terminology. So now we take a quick look at deep learning and neural networks in our next video, so stay tuned.